To do now, solve the following quadratic using quadratic formula. So my first move would be to get everything over to the same side of the equation. 48. All right, we want to have it in the appropriate ax squared plus bx plus c form. Then once we do that, we bring the quadratic formula into the party. So we identify the a, b, and c values. So we got a 4, we got a -4, and we got a +1. So that's a, b, and c. We state the quadratic formula. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. We replace every a with a 4, every b with a -4, and that lone c gets replaced with a 1. All right. So x is equal to, I've mentioned this a few times, I like to run through with parentheses first and then make my substitutions. So everywhere there's a letter, I replace it with a set of parentheses. Bless you. I'm not locking it. There we go. All right, so again, everywhere there's a b, we replace it with a -4. Everywhere there's an a, we replace it with a +4. And that lone c gets replaced with a 1. All right. And again, parts of this will be really easy. So -4, that's not bad. That's just a 4. 2 times 4 on the bottom, also not bad. That was weird. It's the thing under the radical we got to be concerned with. So for that, we bring our calculator into the party. So we take whatever is under the radical and chuck that in there, unless you want to do it in your head or, by hand. I restarted my computer, so I have to reopen everything. Come on, you can do it. Hovering over the wrong thing. There we go. So I take this expression, the parentheses -4, close it up and square it, minus 4 times 4 times 1. Plug that in, you get a 0, which is really the best case scenario. All right, it doesn't always happen, but when it does, that's really nice. Because that means we're only going to get the one solution. Right, because the square root of 0 is equal to 0. This is the same as 4 over 8, which is 1/2. All right. Now, when you get one solution, that means that the original expression was a perfect square trinomial. All right, it would have been nice to know that going in, because we could have factored that much quicker, because we do that all the time when completing the square, page 48. So if I go back, and this question's not asking us to do this, but if I were to go back and factor this, knowing in advance that it's a perfect square trinomial, I could write it as a set of parentheses squared equals 0. And you remember, we take the square root of the first term. That goes here. Take the square root of the last term. That would go here. Carry down the sign of the middle term. That would go there. So you'd have 2x and a 1. It's basically completing the square, except the square is already complete. So then you would take the square root of both sides. You get 2x minus 1 is equal to 0. You don't need a plus or minus when a 0 is involved, because plus or minus 0 is going to be 0 no matter how you slice it. Then you would solve for x, add the 1, divide by the 2, and you get x is equal to 1/2. All right, so knowing that it was a perfect square trinomial would have allowed us to go down that pathway, which, depending on your preference, you may not want to do, but at least at first glance, it seems like it's a little bit less work. All right. So now you get to the idea of well, wouldn't it be nice to know going into a problem whether it's a perfect square trinomial or maybe it's not factorable at all, that you're going to get irrational answers, things like that. That's where this concept of the discriminant comes into play. All right. That's the focus of today's lesson. All right. So that thing under the radical, the b squared minus 4ac, that is the discriminant. The value of the b squared minus 4ac dictates what type of solutions that you're going to have. All right. So the discriminant, really it's not much of a definition. It's b squared minus 4ac. It tells you the number and type of solutions. And type of solutions. All right, so I got this little table here for you, but basically, if we have our quadratic in the appropriate ax squared plus bx plus c form, and we compute b squared minus 4ac, depending on what that value is, we can make a determination of what kind of answer we're going to have. So if b squared minus 4ac is positive, when I say greater than 0, I'm saying positive. So this is positive and a perfect square. All right, that inequality, b squared minus 4ac greater than 0, that's all that means, that the result is positive. And you can see below that, with the squiggly bracket, it says equal perfect square. So if it's positive and a perfect square, then what you're going to get are two real rational roots. And when I say two, I mean two unique real rational roots. All right. What it also means is that the original expression was factorable. All right. So original expression is factorable. So you get two real rational roots, but it also means that the original expression was factorable. So some people look at this and say, and there's two schools of thought. So I'm kind of with you on both interpretations. You compute b squared minus 4ac, right? You get an answer. Let's say it's a 4. That's a number that's positive, and it's also a perfect square. So that tells me that the original expression is factorable. So I could do one of two things. I can go back and factor the original one, like right in the beginning of the unit, factor it into a product of two binomials, set each of those factors equal to 0 and solve. All right, which is probably the easiest way to solve a quadratic. Or I could look at it and say, well, I've already done the hardest part of the quadratic formula, so why don't I just keep doing that? I'll get the answer that way too. Then there's kind of like the middle ground where you're like, all right, well, I'll do it with the quadratic formula, but at least now I know I can check it by factoring. Or I can do it by factoring and check it with the quadratic formula. All right, so it gives you a little bit of a sense of what you should be looking for. Now, the second one is positive and not a perfect square. All right, so I'm just doing a little copy-paste job here. Make some changes. All right, so positive and not a perfect square. It would be two real irrational roots. And the original expression is not factorable. Also useful information. So when you compute the discriminant, and you go through the process, you get the b squared minus 4ac, that's the hardest part of the quadratic, and you get something that's positive but it's not a perfect square, then you kind of look at it and say, all right, well, there's no point in factoring. I'll just continue with the quadratic formula, knowing that I'm going down the right path. All right. The next one, b squared minus 4ac is equal to 0. Well, that's just equal to 0. Right? It's not, I'm not talking about perfect squares or anything like that, positive or negative. The result is 0. That's what happened in the do now problem. In the do now problem, the thing under the radical ended up being equal to 0. That's the best case scenario. So I know I'm looking for one real rational root. It also means that the original expression is factorable. But more specifically, the original expression is a perfect square trinomial. So one real rational root. All right. And that just means one unique rational root. If you solve the quadratic by factoring, you'll get two identical factors. And when you solve, you'll get x equals, let's say, 2, and x equals 2 again. That's one unique value. So there's no difference between the two. So the original expression is a perfect square trinomial. The last one, b squared minus 4ac, is less than 0. All right, so the result is negative. And that's, well, maybe some look at this as the best case scenario. There's no solution. There are no real roots, all right, because you're going to get an imaginary result under the radical. All right, so no real roots. All right, so there's really not much to this, because if you look at the directions below, it says use the value of the discriminant to describe the number and type of roots for each equation. You're not asked to actually find the solutions. You're asked to tell what kind of solutions that they would be. All right, so basically one of these possibilities. All right, so you still go through and identify the A, B, and C values. All right, so looking at number 1, for example, we started off very much the same way we would a quadratic formula problem, identify the A, B, and C. But instead of going into the full-blown quadratic formula, we only go for the part that's under the radical. All right? So the b squared minus 4ac. All right? So everywhere there's a b, and each letter is only represented once, so it's a little easier. You replace it in this case with a -2. The A is a 10. The C is a -9, so I'm going to make that substitution. All right, so we're looking at parentheses everywhere there's a letter, and then we go and fill those parentheses in with the appropriate value. All right, so a -2, a 10, and a -9. Handwriting aside, we just simplify, but we simplify, if you want to do it by hand, you're welcome to do that, but the reason I go crazy with the parentheses is so that I can make it very easy to type into the calculator. So parentheses -2 squared minus 4 parentheses 10, close them up, -9, close it up. So I get 364. All right, so my discriminant value is 364. It's really just a question of, all right, well, what kind of number is that? So that's not the answer to the quadratic. I mean, when we solve a quadratic, we get 2 roots. This is not one of those roots. This is not one of those solutions. But this will give us a clue as to the type of solution we're looking for. So the first thing I notice is that it's a positive number. Now it's just a question of whether it's a perfect square or not. All right, so 2 ways to handle that. One, you could just take the square root of the 364. The other, if you have your calculator set up, I had it set up for something different. If you have it set up to give you a list of perfect squares, you could just go right into the table and see if 364 is in the list. All right, it's not, so 364 it's a positive number, but it's not a perfect square. All right, so that means we're looking at two real irrational roots. And that's all it's asking you to do. Now, I only threw the original expression as factorable or not factorable. I threw that in as like extra information, something that you could look at and say, okay, there's some value in why we're learning this. But these questions are not asking you to make that statement. If you want to throw it in, that's fine, but it's not necessary. All right. All we're doing is identifying how many roots there are and what kind. So 1, 2, none, and whether they're rational or irrational. All right. Well, obviously, if there are none, then we wouldn't care if it's irrational or rational. But number 2, you see that this one's out of whack here. So I'm going to add 6x to both sides. Get it into the appropriate general form for a quadratic. Identify the a, b, and c values. So understood 1 in front of the x squared. A, b, and c. All right, so again, all I need is the b squared minus 4ac. It's not full-blown quadratic formula. So everywhere, or in the one place where there's a b, I would replace it with a 6. The a gets replaced with a 1, and the 8 gets replaced, the c gets replaced with an 8. All right. This one, maybe you do it in your head because it's not that bad. So I'm looking at 36 minus 32, 4 times 1 times 8 with the minus sign. That's going to give you a result of 4. All right, but you can chuck it into the calculator too. You shouldn't need to go to a table of values in order to determine that 4 is a perfect square. But, it's a safety blanket, whatever. So we're looking at a number that is positive and a perfect square. All right, so we're looking at 2 real rational roots. All right, just right from the table, 2 real rational roots. All right, the third one, see, this is much quicker than the quadratic formula. We're not simplifying radicals here. That's usually when people get bogged down in the quadratic formula, that's usually where it happens. And this is much simpler. All right, this is telling me that if I wanted to solve this quadratic, x squared plus 6x plus 8, I don't have to use completing the square. I don't have to use quadratic formula. I could just do it by factoring. All right. The rational part is what makes that determination.
Well, wouldn't it just be quicker instead of just doing this than having to factor it? Wouldn't it just be easier using the quadratic formula?
Well, that's the that's what I was saying before. You have a choice. Once you do this, you can go either way. Yeah.
So we have to do this for some problems?
Yes. So then number 3, I'm going to subtract off the 3 from both sides. Yeah, so down the line, I mean, it's probably too early to talk about this, but when you're in Algebra 2, you're going to have to solve equations that are in quadratic form, but the variable won't be x anymore. It'll be something more complicated, like a trig function, like the sine of x, if you've ever heard of that, or a logarithm. So what'll end up happening is you'll determine the discriminant to make sure that you could solve it by factoring, because in those instances, solving by factoring is orders easier, right? For those more complicated instances where, because we're looking at x as just a variable, but we're going to get to a point where x represents another equation. And if you have to solve it by quadratic formula, it could be a nightmare, right? So this is, we're only in the very rudimentary steps. So it's kind of hard to see why on earth anybody would want to solve or do this. But, there will come a time. It's just, it's a matter of patience. All right, so b squared minus 4ac all right, replacing the b value in this instance with -8, the a value with a +8, and the c value with a 47. All right, so this one I'd probably go to my calculator. So parentheses, -8, just because I have 47. A little beefy. So -1,440. All right, it's not the size of the number that matters, it's the quality of it. All right, it's a negative number. All right, so this is negative. That means that there are no real roots. All right, so that's telling me that whether I do it with factoring, completing the square, or quadratic formula, I'm not going to get an answer one way or the other. At least, I keep doing this, at least until you get to a higher level math class and you learn about imaginary numbers, in which case you'll know that there's this term called I, which represents the square root of -1. You would write your answer in terms of I, but that's 2 years away, or next year if you're taking gap. So the last one, add the 5x squared to both sides. We're looking at 5x squared minus 10x plus 5 is equal to 0. Again, same deal. B squared minus 4ac, parentheses, all right, -10 goes in for the b value. The a value is 5. The c value is also 5, coincidentally. All right, and so -10 squared is 100. 5 times 5 is 25 times another 4, or times just 4, is going to give you 100. Bottom line is this is going to give you a 0. So that means one real rational root. All right. Yeah, so it's a little on the crunchy side when it comes to the knowing the formula and knowing what they correspond to, but that's just studying. You just got to do it. The next page is your assignment, except I don't know what I was thinking. It asked you to use the quadratic formula. I didn't want you to do that. I wanted you to solve using the discriminant. My guess is I couldn't find, it was years ago, so I can't remember. But my guess is that I couldn't find a puzzly type sheet that only asked for the discriminant. So what I want you to, or would like you to do, is solve each of these by finding the discriminant, just the discriminant only. All right. I'm looking at it now. It kind of looks like a lot. Just do the first column. All right. It's the same as your page, except I'm only asking you to do this. So find a discriminant for each one of those. Maybe I'll have another class do the other set. Where I say state the nature of the roots for each, that's find and interpret the discriminant. That's what those instructions mean. All right, do that on separate paper, take a picture, submit it on Schoology. by midnight, please.
Can we do it on the back of that page?
Yeah. Anything that's blank.